So in the last class, we have started Seaborn basics. So we understood its importance over the matplotlib. Okay. And then we have seen what are the different categories of graphs we have in the Seaborn. Agree? So now let's try to see some of the graphs from these categories. Okay. So let's start. Yeah. So let me take my pen. So as we have discussed, these are the advantages of Seaborn. Okay, it provides a layer of abstraction. That means it is much more simpler to use and it has better aesthetics. Aesthetics in the sense it has better features. Okay, and also there are more graphs included when compared to Matplotlib. And there are two ways in which you can draw the graphs, just like in the Matplotlib. One is at the figure level and the axis level. Okay, and these are the different categories. So let's start with the scatter plot, guys. Okay, the way how you need to import. Okay, the way how you need to import the Seaborn is simple. Import Seaborn as SNS. Okay, Matplotlib. When there is also one more famous visualization library in Python called as Plotly. Okay, so that is imported in this way. Okay, fine. So as I said, there like Plotly. Also, there is also one more thing called ggplot. Okay, fine. But we are mostly discussing Seaborn and Matplotlib. Okay, fine. So if possible, I will try to show you some graphs from Plotly. Okay, but let's see. Fine. So the dataset which we are using is a TIPS dataset. Okay, so that is already available in Seaborn itself. Okay, see, we are not loading it from any CSV. From this SNS only, some of the libraries already have some default datasets available in them. Okay, so here SNS itself have load dataset tips. Okay, the tips dataset is already available in the Seaborn library itself. Okay, now this is a tips dataset. We have already seen it multiple times in our previous session, so that's why I'm not again explaining this dataset. Okay, fine. So let's see the graph. So the first graph is the scatter plot, and the way how you can draw is very simple. SNS, now from going forward, SNS will be referring to Seaborn. Okay, now SNS dot scatter plot. Inside this, you need to provide the parameters. Okay, inside this you need to provide the parameters. And just before starting, just to reiterate, as I said, like Seaborn is very important, guys. Okay, so Seaborn is the actual library which most of the people, data analysts or data scientists, will be using, okay, to draw different graphs during feature engineering or EDA process. Okay, so make sure you understand the functions well. Okay, so SNS.scatterplot. Okay, so over here you need to mention all the parameters. The first thing is data, which on you want to draw scatter plot on what data, tips data, and what is your x axis, what is your y axis. Okay, you have a very important useful parameters. Okay, these three parameters, if you see, one is called hue, okay, one is called style, and one is called size. Okay, so if I could quickly show you Seaborn scatter plot. So as I say, always try to follow the official documentation. So Seaborn official documentation is this over here. So you see, for scatter plots, we have so many parameters. Okay. As I mentioned, we are not going to use all the parameters. So most of the parameters will be working with the default values. Okay, but we are going to pass the mandatory parameters like the x-axis, what data, what is the x-axis, what is the y-axis. Okay, now if you see here, we have used these three parameters. Okay, what is this? Hue, size, style. Okay, so you have yeah, so here hue, size, style. Okay, first we'll try to understand the graph and then we'll come back over it. Okay, so over here, if you see, we are plotting. Okay, so we are plotting on the total bill and tip. Okay, this is my total bill and this is my tip. Okay, so first if you take a second and see here, this is my total bill and this is my tip. Okay, so that is plotted. a single for every, let's say 16.99 and 1.01. So this is x-axis, y-axis, and single dot is plotted. Okay, till there it's fine. But we have much more important features over here. So if you see, we are using the hue parameter. Okay, so the dots or the markers which we are using, right? So those you want to differentiate with the help of hue. Now, what is hue? Hue is for the color, guys. Okay, so if you see over here, it will save. Yeah, see here, hue will produce a point with different colors. Okay, size, the size parameter which you see over here, the size. Okay, so that will produce with different sizes. Okay, and next thing you have your style. Okay, style is for different markers. Okay, see here, this is for color, size is for size. Okay, and style is for marker. Getting? So but what is the data point you are plotting? If you see here, it is total bill and YT. Okay, just to one example I will give you and you can understand that. Okay, see here, for example, this last point, okay, 243, it is plotting. Oh, what is this? X-axis is my total bill, and that means 18.78 is my x-axis. So let's say this is my x-axis and this is my y-axis. Okay, now 18.78 and 3. Okay, somewhere it will plot. For example, this is my point for this 243 row. Okay, now this is simple plotting. We can also customize this particular point in many different ways. Okay, first thing is hue parameter is color. Okay, so we can change the color, we can change its color based upon hue parameter. And this, for hue parameter, I am passing what? I am passing another column called as sex. Okay, now how many categories are there in this X column? 2 categories, male and female. So this particular row 243, what type of category it is? Female. Okay, so based upon this female, its color will be produced. That means, see here, for 6 column it has produced 2 colors because there are 2 categories. So male it is assigned for blue and female for orange. Okay, so now this will become orange. Okay, for example, let me take somewhat closer. Okay, just assume this is orange. Okay, now this is done. After that, style in the sense marker. So now for marker, what column I'm assigning? Time. Okay, so over here time, if you see, if I just go above time parameter, so time column, you have 2 things. One is lunch or dinner. Okay, so if I come down over here, my 243 row, this is dinner. Okay, so for time, for style, you are giving time column, right? So over here, if you see time, it is having 2, lunch and dinner, and the marker is different for both of them. Okay, style will be referring to marker. Okay, so marker is dinner, so my dinner is cross. So now it will be same color but with the marker as cross. Okay, marker as cross. That is done. After that, size. Now what is size column? I'm giving it to the size only. Now do we have a size column over here? Yeah, we have a size. That is number of people who have visited. Okay, so based upon this size column, okay, based upon this size column, the size of this particular point or the or you say this marker. Okay, so this one is going to change because now we have, see here, total the unique values in this size column are 6. Okay, 1 2 3 4 5 6. Fine. So based upon that, it has given the sizes. Now ours is 2, so we will have a somewhat smaller marker. Getting? Where it will plot will be based on X and Y. What type of color will be based upon this hue parameter? Now that is from, in our case, that is X column. What is the marker shape, whether it is circle or cross, that will be based upon the style column. In our style parameter, in our case, it is time column. And what is the size of it? That will be based upon this size parameter. In our case, it is a size column. Okay, that means what? If just by looking at it, if just by looking at this one dot or one marker, Okay, one, what we call one plotting. I can tell many characteristics, right? I can tell it is a female. Okay, and I can say this guy came for dinner. Why female? Because the color is orange. Why dinner? Because the shape is cross. Okay, and based upon the size, to some extent, I can say how many people they have visited. Getting, guys? Because for example, if you see here, if you see this particular dot, yeah, this dot. Okay, I don't know what row from the given data set it is, but clearly this is male. Okay, clearly this is male. Agree, because it is blue color, and they came for lunch because the shape is circle. Lunch. Okay, and the size is somewhere around 4. Okay, 3 or 4, 4. Okay, that means what? Just looking at this dot, I am able to say that 4 people, male, 4 people, they have visited for lunch. Okay, and the total bill they have made is somewhere around 35, and tip they have gave is somewhere around 7. Is it clear, guys? Are you guys following? Everybody?
Yes, Santosh.
Others?
Yes, sir.
Okay, these parameters we understood, right? Hue, style, and size. So also, did you see that's the advantage of Seaborn over Matplotlib? I don't see we have these features in Matplotlib, right? So with these 3 parameters, every single dot, every single mark, see this small marker you are seeing, right? So without much effort or tracing back, just by looking at that itself, you can understand this small marker cross is in orange color because this is female, and they have visited for dinner, and the marker is very small in size, so it is just 1. Okay, so one female, she has visited for dinner, and obviously it is only 1. The bill will be small, so it's very small, and obviously the tip will also be small. Getting?
Yes, Santosh.
Yeah, and also it is also logical, right? So as see what is how many members is getting defined by what number of the size. This size is referring to how many members, right? So if you see, obviously if there are more members, the bill will be more, right? So then the size will be more. So that's why if you see when we are going to this side, total bill to the right side, so we are having the sizes bit more, bigger and bigger. Okay, so that's why this is bigger because it is having like it is almost I think 3 or 4. Fine, so that means what? So 4 more number of people visited. So when you have more number of people visited, so obviously the total bill will also be more. Okay, so that's why it is around 35, and when the bill is also more, you can also expect a bigger tip. Fine, these type of insights you can refer it from a single graph from Seaborn. I hope that's clear. Any doubts, guys, from this graph? Because if you understand one, you will understand all its remaining, because it will be just one more extensions to this. But the base graph should be clear.
So, Santosh, so what if we have more categories? So, will it automatically,
Automatically.
for example, instead of six, if there is something else, three
Yeah,
categories are there, so it will give
automatically.
another color.
Yeah. If you see, I'll just interchange these columns. Hmm. Just give me a second, it's running. So now when I interchange, see, Fine. So now hue parameter is my size. Okay. Fine. So in the hue parameter size, that means what the color coding is, hue is color, right? So color coding is coming from size. And now what are the unique values of size? There are 6 unique values. Okay, 1, 2, 3, 4, 5, 6. So it has assigned 6 different colors. Okay. And style is coming from time, and size is coming from 6. Okay, so for male it has given one size, and female earlier for 6 column we have considered color, but now it is size. Okay, so since we have 2 categories, it is assigning 2 different sizes. Now coming to color, which is hue parameter, earlier you have here 6, that means for male 1 color, female 1 color, but now I'm giving size in the sense we are having 6 unique values, 1, 2, 3, 4, 5, 6. For each unique value it is assigned different color. So automatically it will consider any column you give.
Yeah, Santosh, got it.
Okay, fine. So I hope that's clear. So let's move on. So based upon that, yeah. So same graph, okay, same graph what we have plotted, scatter plot. So you can also do it in a different way. So that is from the REL PLT. That means relation plot. Okay. So in Seaborn, so if I just show you, yeah. So Seaborn, we also have relation plot. So relation plot is a I would say at an umbrella level for the both scatter plot and line plot. Okay, what do I mean? So see, inside this relation plot itself, you can draw like line plot or scatter plot. Fine. So for scatter plot, you can directly use SNS or scatter plot. Okay, but both of these are a part of the relation plot. Okay, so using relation plot, and you have a parameter called as kind. Okay, so you have kind over here. If you see this kind, so kind, you can use it for scatter plot or line plot. Okay, so over here when you see, so I'm using SNS dot relation plot. So inside that I'm using the same thing, same data set X, Y. Okay, but I need to specify because relation plot is not the actual plot. Okay, it's just a heading sort of thing. Okay, inside that you need to again specify which type of graph you want to use. Okay, so in this, okay, it's a category. Fine. So that's why if you see over here, the other day when we were discussing, we have mentioned one of the categories relational plot. Okay, so inside that you have scatter online. Okay, so for that you need to mention. So I'm mentioning kind equal to scatter. Okay, the same parameters which you have over here. Okay, so you will be having the similar graph. Clear, guys?
Yeah, Santosh. So by default, if we didn't mention anything, it will take scatter, right?
By default, that's a good question. So we need to see that. So for every parameter which you are seeing over here, right? So it will have a default. Some will be because see data, it cannot use any default, right? So that you need to mention. Okay, X and Y you need to mention. But there are some parameters for which it will be using by default. So see here. So that's why see, go to the official documentation, and for each and every parameter which you see over here, right? So you will have a detailed explanation and also the default value. So see here the parameter is starting, and now for kind scatter. So kind. So here it is saying as default scatter in the sense that by default it will use a scatter. But what all other values it can go for? So come here, come down. So you will have somewhere the kind. Yeah, so here it is saying the kind of plot to draw corresponding to a Seaborn relation plot. Options are scatter or line. Okay, and the default value is they have mentioned over here. So what all the values they have mentioned here, right? So those are the default values. So here it is scatter. Okay, fine. So next thing is, yeah, so let's say a line plot now. So from the, see, we are taking the data set from the Plotly. Okay, so if you see here the PX is my Plotly. Okay, it's also a library. Okay, but we are, as of now we are using it for a data set. Okay, so inside this you have some Gapminder. Okay, data set. Okay, don't worry much about what are these values. Okay, so that will be related to this data specific. Okay, but just see it from the just as an Excel sheet, and columns perspective. So now, okay, first of all, if we see this data set, so what does this data set looks like? Let's see. This data set saying country, continent, year, okay, some sort of values, okay. So inside this, we are filtering it on the country equal to India. So you have this country. So here somewhere you will have India. So we will filter equal to India, and this is my temporary data frame. Fine. So on this data frame, I am drawing a line plot, SNS.line plot. Okay. So if you have observed, if you want to use direct plot, so you can directly say SNS. If you want scatter, you go for scatter. If you want line, go for line. Okay. But if you want to use it from its parent level, so that means SNS.relation plot. Okay. Inside this, you have a kind of parameter. So over there, you need to specify either scatter or line. Okay. So I hope that's clear. So now I'm using directly at the plot level. Okay, so I'm using SNS.plot and simple data. As you can see, I also feel Seaborn is more systematic and organized because it clearly tells you like what type of graph and what are the values and what type of format you are doing. Okay, so inside this first parameter is a data frame. What data set you need to draw the line plot, and what is X, what is Y. Okay, X is my year, Y is my life expectancy, it seems. Okay, so yeah, I think yeah, so this is each country, continent, what is the year, in this year what is the life expectancy. I think it's the population, GDP per capita, ISO alpha, what is this, I am not sure, and ISO number itself. Okay, some values. All we need is just the data. Fine, so we are plotting a graph between year and life expectancy. Okay, so this is simple graph line plot from Seaborn. After that, the same thing as I've just mentioned, so you can also do it from, not if you don't want to do it directly, you can also do it from the relation plot. Okay, so same thing you will mention, but one more extra parameter here you need to mention is kind equal to line. Just like how you mentioned kind equal to scatter, just above here kind equal to line. Okay, fine. So now you are doing a small filter operation. So where you are filtering it from taking 3 different countries. One is for India, Brazil, and Germany. Okay, and this is my data frame. Okay, Brazil, Germany, and India. Now I want to draw all these 3 graphs, okay, in the same graph. So simple SNS.relation plot, kind equal to line. Okay, the position of these parameters is not important, guys. Okay, so you can put these positions at any, these parameters at any position, because if you see here, I have mentioned kind at the last. Okay, so here I'm mentioning kind in the starting. Okay, that doesn't matter as long as you are using the exact name for this parameter. Okay, so now SNS dot relation plot. Okay, I'm saying for example data, what data frame I want to use, what will my X, what is my Y. Okay, fine. Now here X and Y is one thing, and next thing is hue is equal to country. Okay, based upon the country I want to change the color, hue in the sense color. Okay, and based upon the continent I want to change the marker style, and also same based upon the continent only I want to vary the size of the marker. Fine, 3 things. And doing all this, what type of graph I'm looking for? I'm looking for the line plot. Okay, fine. So take X, take Y. So this is my X, this is my Y. Okay, and we have drawn a line plot. Okay, just assume initially they are plotting some line plot. Okay, now the formatting of this line plot will be depending upon this hue and style and size. Agree? So for example, this blue color is regarding the Brazil. Fine, so hue equal to country, that means color. So it is assigned 3 different colors for 3 different countries, because we have filtered on only these 3 countries. Agree? And so Brazil blue. Okay, this is done. And after that, style equal to continent. Okay, now style also, it is giving you 3 different colors. Okay, now Brazil will come under what continent? Okay, Brazil will come under what? America. Okay, so that's why it is thick format. Okay, thick solid line. Fine. So this is Brazil, blue color in thick solid line. Okay, this is the one. Okay, and continent also it is having the size also using the same parameter continent. So you're having three continents, right? America, Europe, and Asia. So the size also is different. Okay, as you can see, this is very, very thin. Okay, and this is a bit okay, but this is very thick in size. Fine. So now that's why the importance is just by looking, for example, looking at this, right? So this particular line, so you can understand what. So this is in which color? So this is in
Green color.
green color, right? So it's
Light.
very thin, but it's green color. That means this is referring to India. Okay, and the marker is this dotted. Okay, small dotted. Okay, that is Asia. Continent is Asia. Okay, and it is very thin in size. So that means okay. But see, that's what when you're assigning the categorical value, right? So it makes sense. For example, the size is very, very thin, but for category that doesn't make sense. Agree? So even what does it mean? So see, you are having a thick for America, okay, and normal for Europe, and very thin for Asia. Okay, but since these are categories that we cannot say that America is greater than Asia or Asia is lesser than Europe. Okay, but if at all these are values, right? Just like in the size we have, right? So in the tips parameter like 1, 2, 3, obviously you can say here the more people are visited, here less people are visited. That you can do. But here we have used it, we can use, but since it's categorical in nature, this will not make much sense. Okay, but it's just for the differentiation. Okay, so Asia is having a thinner size. Fine. So, but if you use here some other life expectancy sort of thing, okay, and if you use life expectancy mean, you can calculate the mean, and if you put it over there, so then it will have some actual significance based upon the thickness. Okay, but overall, this is a way almost similar to what we have seen in the scatter plot. Okay, so hue, style, size, and the kind equal to line. Is it clear? Are you guys following?
Yeah, Santosh. So is it mandatory to mention every time hue,
No, no, no,
style?
no. It is not mandatory to mention all of this every time. You can just say the
Because in
only.
this example, we do not require a size or style like.
Right, right. So you don't need to mention. So for example, if I run this, I'm getting this, right? So I don't want this size. So it's not okay. So as you can see, all three are of same size,
Yes.
right? So because earlier this middle one was a bit thicker. If you observe, I'll just draw it again. See here. See, agree? Because now I don't want. I'll just remove that. Fine. So these, I think these are also not mandatory. Only these three are mandatory. But this
No.
will be everything
Uh,
will be on the same thing. Okay.
yeah.
So at least hue, I think at least hue if
Hue is
you
required to differentiate
the
where
different colors.
exactly three countries.
Okay. But I think style is also fine. Okay, hue and style is fine. You will have marker and also the color differentiation. Till here it's fine. Okay. So but it's not mandatory. The only thing mandatory is data set X and Y and kind. That's it.
Okay.
Okay. Fine. And next thing is, yeah, the same thing, but if you want to draw it directly, okay, so this is the way how you're drawing directly SNS dot line plot and temp dataset XY and the hue equal to country. Okay, so only one parameter they have used. Okay, just now we have seen it. So these are the three. Fine. Okay. Looks like China's life expectancy is way high, guys. So for China, why is life expectancy rate? So it is very, very high. Okay. Next thing is, yeah. So if you have, so in the relation in the tips tips data set. So if you see here, data equal to tips, and I am drawing x equal to total bill, okay, and y equal to tip, okay, and kind equal to line. Fine. So you have two more parameters called as column and row. Okay, so it will just I'll show you in the this parameter. Okay, so for example, you have column and row. So what are these? If you see here, wrap the column variable at its width, so the columns facets span multiple rows, and variable sorry, not this. What is a row and column? Just row and column. Yeah, row and column. Variables are defined subsets to plot on different facets. Okay, so on the row part, what you need to draw, and the column part, what you need to draw. Okay, so for example, you are having, it is plotting the total bill and tip. Okay, and the kind equal to line. Okay, line plot we have drawn. Okay, so but also you are also filter, I would say, representing for the, we have these two columns also, right, in the tips data set. So you have if I just go above, yeah, so you have 6 and the day. Fine. So in row, it is just showing the row wise, column wise. So that means in the, this is what we are having, the row is day in the sense, this is row, okay, and this is column. So it will take the all different categories. Okay, it will take all different categories, combinations from this. That means we'll have Thursday male, Thursday female, fine, Friday male, Friday female, Saturday male, Saturday female, fine. So if you observe what's happening over here, so we have mentioned column as 6. That means what? These are columns, right? So over here I want to represent the 6 column. This is having two categories, male and female. So one will be given for male and one will be given for female. Okay, so that's why if you see, all these graphs are related to male and all these graphs are related to female. Okay, see, male, male. Okay, so even if you come down also, this will be male, this will be male, all males. Okay, and this, and left side, right side is for the females. Okay, so that's why you are mentioning column is female, but row is for day. That means these are rows, right? So this is for day. And in day, what type of categories you have? I think you have Thursday, Friday, Saturday or Sunday. Okay, so now it will create a matrix sort of thing, and all these intersections will be one graph. Okay, this is for Thursday male, Thursday female, Friday male, Friday female, Saturday male, like that. Getting? So Thursday male, Thursday female, Friday male, okay, Saturday male, Saturday female, and Sunday male, Sunday female. Fine. So what type of columns and rows you want to mention for the graphs can be mentioned. Okay, so this is actually considering only those, if you're getting. So it is considering when you're saying this particular graph is for, this is for Thursday male, so it will consider only those data. Okay, it will filter the data set. This is also doing the filter operation directly. If you observe, it will filter the above tips data set. Okay, it will filter the above tips data set on what? On Thursday male. So day equal to Thursday and sex equal to male, it will filter on what data set you are going to get, right? So on that data set, it is trying to draw this graph based upon this total bill and tip. Similarly, it will again, next time it will filter it on the Thursday female, and it will use the total bill and tips data and it will draw this graph. Did you guys follow this particular example?
Yeah, Santosh. Total 3 days and male and female. So 3 to just 6. So 6 graphs in the individually
4 days
displayed.
actually: Thursday, Friday, Saturday, Sunday. So it will have 8.
Oh,
Okay,
okay.
Thursday, Friday,
Right.
Saturday, Sunday.
Yeah.
Getting? And just by looking also graph also, you can make some observations, right? So if you see on Friday, female very less. See, and overall here male is more. Here also male graph is a bit bigger, and here also male is bigger. And see Sunday,
And
so see
Sunday is
Saturday.
huge for both male and female
Hmm?
compared to all other days.
What?
Compared to other days, it's Sunday and Sunday.
Huh. See, for Sunday, see the graph is big. The more number of people have visited, and total bill is also more, and tip is also very high. for male. Okay, and female it is bit less, but compared to in female section, so Sunday, sorry, this Saturday it is bigger, and Sunday it's okay. Okay, but the winner is Saturday over here. Okay, and it is also what do you say, understandable, right? Because mostly people do party on Saturday so that they will have rest on Sunday. Fine. So you can also interchange this column and row with other columns also. So what do you like smoker, time. Okay, just as an example, smoker and time. So smoker will be having yes or no, and time will have dinner and lunch. So you'll have four possible. Smoker is sorry, dinner smoker, lunch smoker, and non-smoker dinner, non-smoker lunch. Getting? Yeah, Sirisha, you guys following any doubts?
No, sir, clear.
Okay, fine. So after that you have yeah, so the same graph, yeah, not the same, this is a different graph, but just one more parameter if you see. So we have seen, right? So the gap parameter, so gap data set. So you're having life expectancy, GDP per capita. Okay, I'm drawing a scatter plot. Why I'm specifying this kind specifically? Because I'm not directly plotting scatter. I'm using relation plot over here. Okay, and inside this is a column here I'm using. Okay, but this is also we have seen, right? What is this? Because just now we have seen the column here, in the sense the year should be column. Fine, but there is one more parameter called as call wrap equal to 3. That means there should be 3 columns in each row. That means this is one row. Here there should be 3 columns. 1, 2, 3. Okay. So otherwise there will be when you say column, it will use all the years in just one single column. Okay, that I don't want. Fine. So it is just I want to wrap 3 columns in each row. The meaning of this call wrap is how many values you want to have in, how many graphs you want to have in each row. Okay, so anytime just go over, wrap the column wrap. So it is saying wrap the column at its width so that the column face should span multiple rows. Okay, so this is a number of columns you want to wrap in each row. Fine, so this is clear, simple parameter. Did you understand what is column wrap?
Can you please run without a column wrap solutions?
Okay.
Okay. In a single.
Each column is one row. Okay. Oh, I thought I said this one, right? So this is the row side. So each column, in each column, it will be 1 year. Okay, because if you go above, same thing. So when I say column equal to 6, that means each column will be 1 6 category, right? One is male, one is female. Getting? This is male. Next column will be female, like that. So here also, if I don't mention anything, so each column will be 1 year. So if you cannot see this, but this is 1 year, this is another year. That means every column is 1 year. Okay, so in other sense, it is creating only one row. Okay, so but if I don't want that, like for example, if I take 4,
so it's divided 1 row into 4 columns now.
correct. So I'll say call wrap equal to 4, so it will create 4 graphs in one each row.
Okay.
Like this. Okay.
Okay.
Fine. So that's mostly about the relation category plots and scatter plots. Okay. Fine. So after that we have distribution category. Fine. So over here in the distribution category, you have mostly we'll see histograms and KDs. Okay. So but these two are not new for us. If you followed the previous sessions, okay. So both of these we have seen in the statistics module. Fine. So histogram we have seen in the matplotlib also recently. Coming to KDE kernel density estimation. So this is just a smoothing of the histogram. So if you remember, so if you have histogram sort of like this, okay. So KDE is kind of it will just also, instead of giving the histogram, it will just try to give you the what type of graph it was. Okay. So which we have discussed in the stats module, right? So coming to that, so see, distribution plots used for univariate analysis, that means single column analysis used to find out the distribution, okay, and range of the observation. Central tendency is the data bimodal in the sense what? So this is single model, this is bimodal. So these are modes, right? And are there any outliers? Okay, fine. So now in this you are having plots like histogram, KDE, reg plot. Okay, reg plot is not that common. We don't use it mostly at all. Okay, so histogram and KDE plots are important, so we are going to see that. So here histogram, so tips dataset we are using the same tips dataset. Fine. The total bill column we are plotting. So the way how you need to pass the parameters extremely simple. sns.histplot. Okay, inside that what data frame you are using and what type of column you want to use. So total bill. So these are the total bills. Okay, and as you know, the histogram will be continuous in nature. Okay, histogram, there will be no gaps, mostly there it will be continuous in nature. Okay, and it is giving you the what is it saying? So it is saying these are the features, these are the values or bins. Okay, and this is a count. And how do you understand this? So it means that from the total bill, okay, what is the total bill parameter? So total bill is having a particular range, right? So what, see, starting from some 10.34 could be the lowest, and some maximum value will have something. So okay, start whatever be it is, okay, from minimum value to maximum value. Okay, so the bill, the total bills ranging from let's say this is 0 to 5, okay, some range 5. Okay, so from 0 to 5, the count of total bills which you got is somewhere around 3. Okay, so the meaning is that, for example, this is, let's say, 12 to 15. Okay, total bills which are falling between this 12 to 15 range, okay, the count of those is this. Okay, by default the y-axis for the histogram will be count or frequency. Fine. So that means what? Most of the people have paid bills falling in between this range. Okay, this range. And if this range, for example, it is 12 to 15, that means most bills the restaurant got is between 12 to 15. Okay, it is around almost 50, like 47 sort of thing. Okay, and very low bills are less in count, and also very high bills also less in count. Okay.
So Santosh, now if you want to calculate between 10 to 20 range total bills, so we need to sum up between all those three
Correct,
ranges, right?
correct,
Account
correct. This is, yeah, 10 to 20 in the sense of this plus this.
frequency, like count,
Frequency, yeah,
maybe 45 plus 50
correct,
plus, yeah.
correct.
Yeah.
Fine. And after that, yeah, using the distribution plot, you can also draw his plot. Okay, so distribution plot for data equal to tips x, y. Okay, same thing, kind equal to hist. And yeah, so total bill. Yeah, so here these are bins, right? So these are bins. Each bar or small building which you see over here, right? That is called bins. You can also specify how many bins you want. So here, that total bill, I want to just divide into 2 bins. Bins equal to 2. So okay, same distribution plot, kind equal to hist. So from starting to end, it will just divide into 2 parts. Okay, one is something around like 27. Okay, 0 to 27 bills. So this is a frequency, and remain 27 to 50. This is a frequency. Okay, so you can divide it into different type of bins also. Okay, see, so you can give any number, 3 also I can give. Okay, see, 5, any type, any number of bins you can give. Okay, fine. And distribution plot tips x equal to day. Yeah, so for the day also you can give for the day in the sense what categorical column, right? So it's also possible to visualize the distribution of a categorical variable. Okay, so instead of using total, which is numerical value, so we also have the categorical day. Day in the sense what? Thursday, Friday, Saturday, Sunday tips data set. So for Thursday, what is the count? For Friday, what is the count? And Saturday, Sunday. Okay, what is the frequency? How many Thursday visits are there? Friday visits are there? Saturday, Sunday visits are there? Fine. So that is for the day. Okay, Thursday, Friday, Saturday. And I think time, what is time? Lunch and dinner. Fine. So this is for lunch and dinner. Agree? And one more thing is smoke. Okay, how many smokers? Parameter of smoker. Go on with the parameter of smoke. I think there are some null values over there. Okay, so we can handle that. But we have a 6 column. Okay, so we have male and female. Fine. So any column you can consider. So say, and here also you have the features which you can apply. So distribution plot, data, x, kind. Till here, I think you are good. Hue is also you are like aware of now. See, aware by now, but what is this hue defined? Hue refers to color. Fine. So you are plotting the tips data set. Okay, on tip, the actual tip. Okay, not the total bill. Tip. You remember? Where is this? Yeah, the tip what they have given, right? So that parameter you are only this column you are plotting. Okay, and that you also want to differentiate. Okay, with the 6 column color code. Okay, so in this, for example, this, okay, this one, okay, over here, this is a in this range to this range, that means from 2 to some just 2.4 or something. This many people have given, for example, this is 2.2 guys. Okay, now, and this is 35, for example. Okay, 35 tips were given between the range 2 to 2.2. That means 2.1, 2.1.5, 2 point something like that. 35 tips, count is 35. 35 tips were given between this range. Okay, that is fine. But in that, how many male and how many female? Agree? So this will tell you the male and female, right? So this got overlap. That's why the color got changed, because when you overlap this orange color and blue, I think you'll get gray. But this, wherever you are seeing this gray, that is referring to the female F. Okay, and the remaining, this one is a male. Okay, so this many female people, this is a female contribution in that, and this is a male contribution in giving the tip. Okay, that you can achieve by the hue parameter. Okay, so same thing. This is also, this is from 4 to some 4.3. This 6, what is this? 14 people have given the tips which are in ranging between this, and in that, this is a percentage of male and this is a contribution of female. Okay, fine. So that's about the hue parameter. And the same thing what we have done here, right? So same thing we have done here till here, but only one extra step is element equal to step. Now what is element? Element equal to step when you do, right? So it will just give you the graph in an outline sort of thing. Okay, so now if I show you the graph, see, so nothing different. Okay, but just it will give you the outline sort of thing, the element. Okay, not that helpful, but just good if you know one more extra parameter. Okay, but these are more looking better. Okay, fine. So after that, if you see, you have the graph. We are loading the Titanic dataset. Okay, so you are a bit familiar with Titanic dataset, right? So survived, passenger class, sex, age, okay, CBSP park, fare, embark, okay, etc. Now from this graph, if you see, we are trying to draw histogram. Okay, for age column, we are trying to draw the histogram. Okay, and you want to segregate it on the, sorry, color code it using the 6 column. Fine. So now once I do this, see, these are the age and count. Okay, That means from what? So from 10 to 20, from 10 to 15, these many are the female. Sorry, this is a age for the female and male. Fine. So this blue is for the male. Okay. Actually, this element is not looking good. I do not like this element. So what I will do is I'll just let me run this and remove the element parameter. Outline, the actual one is only better. Yeah. Fine. So it is saying, okay, I'm drawing age. Okay, but age I'm drawing with what? For male and female. Okay, so for these blue ones will be for the male. Okay, the histograms, and for the orange one will be the female. That means in this bar, okay, this bar, let's say it is from 15 to 20. Okay, this bar, okay, 15 to 20. This is a count. Almost 50 people are present whose age is falling between 50 to 20. In that, this is for the male, okay, and this is for the female. Okay, fine. Oh, sorry, I think this complete is for the male, guys. I think this got overlapped on top of it, right? So this for the male and this is for the female, because if you can see here, so this is for the overall blue, but if at all you have female also, it will just overlap to some extent. Okay, but mostly you can see females are having ages less than the male. Okay, more young females were there in the Titanic. Okay, and you can use one more step, like data set chip x all is cool and column equal to 6. Okay, since we understood basics, so it will just the a repetition across different data sets. Okay, so now if you see the column equal 6, so you can have it in 2 different graphs. Getting? So because in each column it will use this 6 column, it will take the categories male and female, and it will, for each column it will give, this is one column is for male, one column is for the female. Okay, this is for the tips, male tips. Okay, male people how many tips they give, that is that histogram, and female people how many, what tip they give, that is its histogram. Is it clear, guys?
Yes, sir.
Yeah, Santosh. But Santosh, I can see like pasting using call and row not work on the histogram. I didn't get that comment. What exactly it is? Not work on histplot function. Is there anything special like
This
call?
pasting using column and row not work on histogram. Not sure. So if I use row column, yeah, you are getting not on histogram. Not sure, man. I will check.
Okay.
Okay. So next thing you have, yeah, KD plot. Okay. So rather than using discrete bins, a KD plot is smoothing observations using a Gaussian Keller, producing a continuous density estimation. Okay. So shown, right. So instead of using this graph, so KD will give you a kind of estimation graph. It will give you, okay, what type of the distribution, Gaussian distribution looks like. Okay. So for the total bill, if you see the total bill, this is a graph. Okay, so for example, histogram, right? So data equal to tips, x equal to total bill. See, this is my histogram for the total bill. Okay, it is somewhere around like this, like this. Okay, this is the same total bill column, but for the KD plot. Okay, so see. Okay, so it will give you the estimation sort of thing. How does a graph look like? Fine. So that you can achieve from KDE plot, SNS.KDE plot. Okay. And you can same thing. So from distribution plot also you can do, but you need to present kind equal to KDE. Fine, same graph. And here again you have the parameters, okay, data equal to tips x, okay, and you want to draw the KD plots for male and also female, okay. So now male is this one, male, and this is for female. Fine. And you have different parameters, fill, height, aspect, okay. You can explore that as I've just shown you. Fill is for true. If you don't fill, see, you can quickly run this, okay. Fill, if I don't use fill, okay, I think it will just give you the graph. Yeah, so it is not filling the it's the color with this, okay. And height is the what height what we want, and aspect is, I think it's for the transparency, okay. You can just explore what is the meaning of that in this documentation, okay. But this is the way how you can draw histogram from the distribution plot, okay. So in distribution plot, kind equal to KDE. So this parameter, now if you change it to day, it will give you for four different days: Thursday, Friday, Saturday, Sunday. Okay, is it clear?
Yeah, Santosh.
Fine. So that is regarding the so we have seen the scatter plot, line plot, histogram, KDE plot. Fine. So next you have matrix plot, okay. So I'll just discuss heat plot, and we can see the remaining cluster plot in tomorrow's session, okay. So see here, guys. So now if you see here, heat map, we have already seen it in the matplotlib, right? So over here, if you see, I am considering the gap. What is this gap? The country continent data set we have seen, life expectancy, you remember? So that one I am creating a pivot table, okay, using this, okay. So now if I just show you this data set, see, this is a pivot table I am creating, okay. What does this mean? So index is country, okay, different, all countries, and column is year, so all years, and the values I want to plot is the life expectancy. This is my life expectancy. So Afghanistan 1957 life expectancy, like that, okay. So on this pivot table, I am drawing a heat map, okay. The same values I am showing it on the heat map. I think we have already done this in the matplotlib, but in Seaborn, let's see, okay. Now the way how you need to do it in the Seaborn is sns.heatmap, just heat map and pass this data frame, okay. This is just to control the size of the figure, okay. PLD.figure. Fine. So now sns.plot, sorry, heat map, we have one data frame. So you see, so it is giving you the color codings, okay. So just take a moment to understand this. So it has given all the Afghanistan, Albania, Algeria, Angola, okay. So all the graphs, okay. And these, and based upon these values, okay, based upon these values, right, so it has given the color coding. So starting from some 0 to 30, 40, 50, 60, 70, maximum somewhere 80. Do we have something greater than 80? So I don't see anything greater than 80. We have something 70, 73. Okay. So max is 80. So it has given the color, and based upon the value, it has given the color coding. Okay. So for Afghanistan, it is like dark. Initially, it is very, very dark. So see, are you able to understand the significance of this, guys? So because just by looking at the graph, okay, you can understand whether the life expectancy is increasing or decreasing in a given country. For example, in Afghanistan, it was very dark and slowly it has become a bit lighter. That means what? From dark to light means what? It has started from here, this dark color to light. That means life expectancy is increasing, but still it is not that great, because still at the end also it is still dark. Agree? So it is still here, it stopped here. So because if you see the life expectancy is C, 1952 life expectancy is just 28, and still in 2007 also it's just 43. Okay, are you guys following what I'm trying to say?
Yeah, Santosh.
Or shall I repeat?
Repeat, sir.
Repeat, Meghna?
Yes, sir.
Yeah. See, this pivot table, you understood?
Yes, sir. Understood.
Okay, so the same thing, see this one, these values, it is showing in the shape of a small color line. Okay, now this, what are the values you're seeing over here, right? So it is representing using this line. Okay, the same graph, the same thing, it is representing in the form of this line. And what is this line? This line is coming from this color code. Okay, so first of all, it will take all the values. See, first of all, not on this, first of all, it will consider all the values across all the rows. How many rows are there? 142 rows. Okay, from 142 rows and 12 columns. Okay, so how many you will have? If you do 142 into 12, you will have those many values, right? So let me do that. Okay, you will have better understanding. Okay, so 142 into 12, see 1704. Okay, 1704 values, it will first, it will understand. Okay, and it will sort them, in ascending to descending order. For example, it is starting from, as an example, the lowest value is 30 and highest value is 80. Fine, so in between this you are having 1704 values. Okay, every value you pick, it is falling between this. And now for each and every unique value, so there are, see, even though there are 1704, it might not be, all might not be unique. Okay, but because these are, they are considering till decimal, 3 decimal value, right? So mostly there are chances that all of them are unique. Okay, if at all they have considered only integer like 55, 57, so there might be mostly duplicates, because if you see, this is 50 and somewhere also you can find some more other 50. See, this is also 50. So if you consider only integer value, so this will be obviously duplicate. But here they're considering till third decimal. Okay, so obviously there will not be any duplicate. So consider there are 1704 unique values itself. So from this range 30 to 80, you are having 1704 unique values. Fine. So for each and every unique value, it will assign a color. Okay, like that, it will create a color for each and every value, and it will start from some dark. So this color you can change. Okay, as of now, it is starting from light color, dark color to light color. Okay, that means what? The 30 will be having the darkest color from the given color code, color bar, and the 80 will have the lightest color. Okay, so if you see here, see the 30 or 0 is 0 in the sense like a very lowest value is having the very dark color, and when you go above, you will have the light color. Okay, so this will be given first. It will assign a value for each and every unique value from this 1704 bucket. Okay, once that is done, now for each and every column. Okay, so once this is done, so then it will consider 28.801. It will see in this color code where this value is falling. Okay, it is falling somewhere around 28. Sorry, actually the minimum value is we have considered 30, but it is 28. Okay, for example, let's take this only as our minimum value. What is 28.201? Okay, 28.801. Okay, so 28.801 is the minimum value, and it should have the darkest value. It will put in the place of this, it will create a very dark color. And 30 is just above. Okay, it will also darker. Okay, like that, a bit lighter than this, bit lighter, like that. It will replace this values with its color. So ultimately we'll have a color code for this line. Instead of this values, you can see a color bar. Getting? Now 55, where is this 55 falling in this range? It is falling somewhere over here. And what is its corresponding color? It's a bit lighter color. You understand? So over here 50, 55. Over here, if you see 50, you will have 55 over here because this is 60. So the color is little lighter when compared to this darker, right? So it will replace this 55 with a somewhat lighter color. I'm not using different colors, but just assume this will be a little lighter color. And 59 is more lighter color. Okay, 64 is bigger value, so it will be more lighter in color. And as you come here, 676, it is still lighter color. Okay, it will replace all these values with corresponding colors. Now this will have its own color code line. Color line. It will have its own color line. Getting now?
Yes, sir. Understood.
Fine. So like that, each and every value will be replaced with its color. Okay. That's how it is clicking. But now you can think what's the importance. Okay. See, by looking at these values, I cannot understand anything, right? But by looking at this color, we can clearly understand. See, for example, see, life expectancy people in Afghanistan is very terrible. Okay, see, it's very, very dark. But if you see Denmark, for example, if you see Denmark, I don't know, I did not say any values of Denmark, but just by looking at this graph, it's almost, see, white, almost white. because the people are living very happily over here. And it is also, I think, sometime I read that Denmark is the most happiest city in the world. Okay, happiest country in the world. I don't know. Finland. Okay, Denmark should see. Second one is Denmark. Okay, so earlier when I read, it was the first. Okay, so Denmark was one of the happiest countries. So obviously, when you're happy, your life experience will also be high. See, for the Denmark, it is there is no dark at all. They started it from the light. I think they have started somewhere around 60 plus, and now they are in. This is Denmark. Right? There are around 80. Okay, there are around 80. So that's why if you see. Okay, so if you see, this is my temp DF, right? So now this is also my pandas data frame. Okay, now if I dot log okay, now these are the values for Zimbabwe. Now I want for Denmark. What is my Denmark? DENMARK. Okay, see guys, as expected for Denmark, it will be somewhere over here. So these are the values. It started from 70 and they are going till 78. Very happy people. Getting? See this color. Okay, see who's this guy? So this guy is very, very dark. See, Guinea Bissau, there is some country, Guatemala. Okay, see they are very oh my god, see this is completely black, pitch black. Romania. No, what is this? Is this Romania? No, Sotam and Principe. I don't know what is this country also. So, but there it's having pitch black. I think very, very less. Okay, and if you see India, okay, let us see the our own country. Fine. So if I go for India, oh, we also started with 37 and now we are 64. Not that great, but that's fine. Fine. So over here, if you see India, this bar is for us. Getting is how you can interpret this graph.
Yeah, Santosh.
Okay. So, but now if you see, if you say, Santosh, this is fine, but I also want to see the values also. Okay, along with this, that is also possible. So if you just come down, so when you say there is one parameter, so the same thing you are drawing in this sense for the only for Europe, continent. If you draw the life experience, whatever we have drawn it, right? So instead of all the contents, if you filter it on only Europe and if you draw, you can do that. But one more thing you can add is something called as annote, which will stand for annotation. Okay, these are values or annotations, right? So that thing, if you use it for true, fine, then you will also see the values, which is more helpful. Okay, usually we use annotations also. Okay, so here you are not using any annotations. By default it would be false. Okay, but if you do annotations equal to true, for example, let me try, will it work over here? Okay, since we are drawing it from the full data, yeah, so yeah, see, it's giving values. You can customize this using this figure size. Okay, if you can increase this figure size, it will be better, but you can also see the values. Okay, but here it will be a bit clear. See, for the Europe continent, and we are plotting what the life expectancy. Okay, and my columns are year and index is country. Fine. So these are my different countries in Europe continent. Okay, so just like how we filter it on what we have filtered it on the country and year. Okay, all countries, but here we are first filtering it on Europe continent. In that Europe continent, we are taking all countries. Okay, fine. So I'll also show you this data set also. See, this is my only countries in my Europe continent. Fine. So in this, you are plotting. So when you plot this, as I said, annotations equal to true. Remember this. This is very helpful. So this will also give you the values. So it means what? For example, if you see for Albania, the first one is Albania, right? So Albania, see it's 55, 59, right? So these values are these 15, 55, it is considering integer values, so 55, 59, right? It is also given the color code also. Don't miss that. It's also given color code. The same thing happened over here. See, right from these values, every value what we are seeing here, right? So all these values are considered and they are sorted, and then a color code is given for each and everything, each and every value from this, fine, and then from that unique value is considered. Okay, so but yeah, so from this it's a learning a quick thing we can check here is, since it is considering only integer value, fine, so then you can have the unique values. Okay, earlier when we have discussed, I was saying, right, so actually it is considering 70.774 and 70.420 as same, both will be considered 70 because it is considering only integer value, not the decimal. Okay, so obviously previously we have 1704, right? So from that you will consider the unique values, only unique values, and it will assign those color codes. Okay, now here also if you see, even though you have 67 point, it will consider only it has 67. So that's why if you see here, for example, this row, Bosnia row, you are having 71, 71. Okay, where is 71 Bosnia? See 71.140 and yeah, Bulgaria, yeah, 71.080, 71.340, 71, all these 71s will be considered as 71 only. Okay, getting fine. So that's why you see all 71, 71, 71. Okay, fine. So what has happened? So it has considered all the values, then it has considered the unique values and given each value for one unique value, and that's how the color bar is created. This is the color bar. Okay, starting from the lowest value and going to the highest, and these are the different colors. Okay, and based upon that, each and every value, okay, for each, for example, United Kingdom, for every value it will give you a color code. That's how this particular line is created for this United Kingdom, and also it is, when you say are not equal to true, it will also show you the values also. Okay, so that's how this is created. Getting guys? If you don't do this, you cannot see the values. It will just give you the color code. Okay, which is not that helpful. Let's have the values. This you can do. Getting?
Yes, Santosh.
Any doubts?
Can you please go up once? So here columns equal to year.
Columns equal to year, yes.
So year wise it will take, and values equal to lifespan. Okay, individual.
No. See, this one is a data set which we are creating. Okay,
Yes.
so you should.
Yes.
This is the data set. Okay, see here. These are the columns. Column equal to year. First,
Yes.
you are filtering on Europe continent. That means it will consider only Europe. Inside that, all the countries whatever you are having, right? That is my
Yes.
index country. These are all countries.
Yes.
And the column is year. These are different years. And in this country, in this year, what value I should plot? That is life expectancy.
Yes. Okay.
Okay. Fine. So if you remember this color coding, if you don't like, you can also change it. So if you remember, in place of winter, you also have something called as summer. You have also winter. Okay, it will give you a different see color coding. This looks great. Okay, blue color. And Viridis, I think you also have something called as Viridis color. Okay, see, this is something similar. Okay, but I like winter color. This color is okay. Like that, you can explore different options for this parameter. Fine. So yeah, same thing again. So looking at it, you can understand Turkey is also having very less expectancy. And who is the happiest in this continent? Yeah, in this continent, who is the happiest guy? Let's see who is starting with the maximum. Mostly, if you observe, life expectancy is always increasing. Okay, though it might be smaller, so it will always increasing. I don't think it will decrease. Okay, even it's a small increase, also it will increase. So let's see which particular country is having the highest in the starting year itself. Okay, so 72 Iceland, 73 Norway. Yeah, Norway. So Norway guy is also does Norway is in the happiest country list? Yeah, see, these are also one of the top happiest people. So Norway starting with 73 itself. In what? In year? What is the year we considered? In year 1952 itself, they're having the maximum life expectancy. Okay, so as of now, in 2000 7, we have considered 2007 only. How much it is for Norway? 80. 2007, now 2024. Now I think what is the life expectancy? Are you interested in to check? Let's see. Norway life expectancy 2023. See 82.94. It has increased. See Norway 80, now it is 82.94. So that is regarding the seaborne heat map. Why it is heat? As I said, like it looks like, so when you heat something, so the heat, how do I say it? So it distributes, right? So in some parts it will be like more hotter, and some parts it will be not that. So you can see the waves, right? So if you try to visualize it, right? So it will be similar to that. Okay, these are, let's say, temperature degrees. Okay, how hot this one, how cold is this one. Okay, so this is, let's say, it is very cold. As we're increasing the temperature, it is becoming hotter and hotter. Okay, so something like that. Clear, guys? Following?
Yes, sir.
Cool. So that's regarding about the where this one heat map from the matrix section. Okay, and tomorrow we are going to see the cluster plot, and then we'll see these categories section. These are all small plots, I think, and most of this we are already seen. Bar, you know, count, you know, box, you know, but still in Seaborn it will be much more easier and interesting, and violin will be very interesting. Violin plot is one of the most important plot because it will be a combination of box plot. Okay, and then you have swarm plot is new, and I said pair. Tomorrow we'll also see pair plot. Pair plot is one of the most important plot, right? The first thing which you do is will be the pair plot, and joint plot is also important, but the pair is very important. Okay, so remaining plots we are going to see. Let's see if tomorrow we are going to conclude Seaborn. Okay, if possible, I'll also show you a few more examples for each plot, and that should conclude the Seaborn, right? So post that I have already started creating the notes for ML. Okay, so coming to ML part, right? So my idea is once the Seaborn is concluded, let's say in max 1 or 2 days, once that is done, right? So we are going to I'm going to start with the ML. Okay, so trust me, ML is going to be very interesting, very helpful for you guys. Okay, and what all we have studied till now, that we are going to enjoy all those things in the ML part. Now I'm going to start ML from very scratch. Okay, so even before feature engineering also. Okay, even before feature engineering, or actually I thought of feature engineering and EDA, but yesterday when I was doing a small research, I understood to start it in further low level, so that it will be very helpful for you guys. So I'm going to start it from very scratch level, right? And we are going to discuss lot of things, and personally I'm also much curious to talk about ML. Okay, but this is a long journey which we have come till ML, right from Python till here. Fine. So as I said, be attentive in next few months. Okay, so what all we have studied, that is going to be definitely helpful. Fine. So we are going to start it from actually very basic, like what is ML sort of thing, and what type of applications we can build using ML. Okay, so from that, starting from that zero level, so we are going to study lot of things I'm going to say, and we are also going to see end-to-end projects, and how you can deploy, and how you can actually use it on some web UI. So that will be the graph from ML learning, right? So that will be interesting. Fine. Cool. So just I wanted to share about that. Fine. Yeah, guys, that's all from my end. Tomorrow, let's join for the Seaborn. Okay. So yeah, so just give me a second. So let me am I gonna just stay for a second? 1 second. Let me stop the recording.
So Santosh, like